Bismillahirrahmanirrahim. In the name of Allah, most gracious, most merciful. طبعا today, inshallah, I mean, as you see, we will continue talking about the ray diagram. Here in the figure in front of us, we have the object. We put the object on the principal axis. We said that there are certain points. These points are so important to be located in front of the mirror. Okay, this is the pole. Okay, this is C, this is F. Okay, well, here this is C, which is the center of curvature. This is F, which is the focal point. Let's remember that this should be equal to this. Okay, we put the object, the base of the object, on the principal axis, which is this line that connects between the C, the F, and the pole. Okay, from the head of the object, we will send three types of rays. Okay, we should be able to know these three types of rays. Those are called reference rays. But in fact, whenever we want to make a diagram or ray diagram, we will use only two of these three, but we have to memorize all these three. This is the first one. This is the first one. From the top of the object, we will send the ray parallel to the principal axis. This ray always goes to the focus and pass through the focus. This is the first reference ray. Okay, well, the second reference ray is that one. This is the second reference ray. It's literally, or it's, let's say, it's opposite to the first case. In the first case, the incident is parallel and the reflected passes through the focus. Okay, here the incident ray is passing through focus and the reflected is parallel. Okay, so this is the second ray. The third ray or reference ray will pass through this point. This point is the center of curvature. Center of curvature, what? Of this surface. This surface is spherical. So any ray from the center to the sphere is perpendicular to the sphere. So it will reflect on itself, okay? Because it represents a radius. Okay, let's see. Look. Now we will emit this ray. It reflects on itself. It reflects on itself. So the question now, what is the importance of this? Because we will search for the point where any two rays of these three rays, by the way, these three rays should meet each other in one point. Okay, so wherever these three rays meet each other, the image of the head will be formed. Where is the image of the base of the pen or the object? It's here on the principal axis. Where is the image of the head? It's here where they meet each other. Let's see here. This is the image of the head. So it means we found the image. The head here below the principal axis, so it's inverted. It's inverted. It's in front of the image, so it's real. By the way, we have to say that this is the height of the object. It's h. Okay, it's positive, by the way. Why? Because it's up. Okay, but if I ask you, what about the height of the image? It's negative h dash. It's the height of the image. Okay, it's negative. Why? Because it's inverted. It's below the axis, and this point is very important to be said. Okay, well, now inshallah, let's clear the drawing. Now, inshallah, we will, or this table summarizes all what we said. Here, the first case, okay, the incident rays are parallel to the principal axis, and the reflected ray is through the focus. The second one is the opposite. It's the incident ray is falling through focus, and it's parallel. The incident, the reflected ray, it's parallel to the principal axis. And the third case, the incident ray is passing through the center of the curvature C, which is the center of the sphere. Okay, so it falls perpendicular to the mirror, so it will reflect back along itself. Okay, alhamdulillah. Well, now inshallah we will talk about a very important point. This point is something that we call ray diagram. Ray diagram of concave mirror. If you remember, I avoided to say concave mirror in the beginning, okay? But let's remember the following. Concave, cave means the reflecting surface is this, the cavity of the mirror. So this smooth part is the reflecting surface. So concave mirror, concave in the mirrors only, in mirrors means converging mirror, because in the lenses, inshallah, there will be it will be the opposite. Okay, but here let's see together how can we use these rays to form the different cases, or what we call the ray diagrams of different cases of images formed by the concave mirrors. Let's see. Here, number one, we put the object on the principal axis. This is the first case. If I want to describe the first case here, I'll say that the object is far from, or farther from, than the center of curvature. Or I can say the distance between the object and the mirror, which is P is the distance between the object and the mirror. Okay, P is more than 2f. What does it mean, 2f? We said that, sorry, 2f, f small. We said that this is f small. This distance is 2f small, okay, or r, which is the center of curvature, which is the radius of curvature, okay? We said that in the first period, or in the second period. Well, well, so we can say that here, this P is the distance between the object, P, the distance between the object and the mirror, okay, is more than 2f, okay? If we want to sketch or expect what will happen, let's see. We will send the rays we talked about. in the previous slide. Okay, these are the three rays. We need only two of them, so use any two of them. I'll send the first ray, number one, parallel, okay? So it will reflect passing through the F. Then I'll send the second ray through F, so it will reflect parallel. Where will they meet each other? Okay, here. So this is the image of what? This is the image of the head of the object. Okay, where is the image of the base? The image of the base is the image of the base on the principal axis. Okay, so the image will be here. The image will be here. So this is the image. Can I suggest or guess the properties? Yes, it's in front of the mirror, so it's real, and real should be inverted, okay, or upside down, okay. It's between F and C, between F and C, okay. Well, let's see. So here, this is the image. Let's clear drawings, okay. So this is the image. Well, now, inshallah Rabbil Alameen, we will bring the object closer to the center of curvature, okay? Now it's farther from the center of curvature, okay? Let's see. We will bring it here now. As the object moves towards the center of curvature, what happens? The image increases in size till the point where the object reach the center of curvature. The image will meet the object at the center of curvature, and their heights will be equal. Okay, well, in each case we send two rays. Here we will bring the object closer. Closer means what? Means here, but this is the next the next point, the next suggested point between C and F. Okay, so yes, now the image becomes larger. Okay, so the image becomes larger when the object is between C and F, and it's inverted, it's real. Well, now the next step is where is F. Let's see what will happen when the object is at F. What is the two rays? The two rays, one is parallel then reflected to the focus, and the other is passing through C, so it will reflect along itself. They are parallel, so they can never meet each other. So in this case, there will no be images. Okay, let's see the next step, which is surprise, inshallah. Let's see. Yes, in this case, the object is beyond or between F and P. Okay, this is the first step, parallel. Where will it go? It will go to F. Let's see. Yes, okay. What about the second ray? The second ray, it's difficult here to say the second ray is passing through F, okay, because it's too close, okay. So we will send it to C and it will reflect. Yes, we will send along C, sorry. So these are the reflected rays. They are going far from each other, and we agreed together if the reflected rays are going far from each other, so we have to extend them to meet each other behind the mirror. And whenever we say behind the mirror, we are talking about what? Huh? About what? Real or virtual image? Huh? Excellent answer. Virtual image. So we extend these rays to meet each other behind the mirror. So it's the virtual image. Do you observe? If the image is virtual, it will be what? It will be upright. So I asked you to make pairing between the description virtual and upright, and these make one pair. The second pair, real and upside down. Okay, well, so this is the ray diagram, or the method of making ray diagram. Okay, but there is a very important case that we didn't explain. This is if the object is, look at this, if the object is at infinity. What's meant by at infinity? Like the sun, like the stars, like the moon, any object like a very far lamp. Okay, any object that is very far from us, we consider the incident ray, the incident rays, those are coming from it, we consider them parallel. We consider them as if they are parallel to each other. Okay, so these are parallel to each other. So these are parallel to each other, and we will consider they are parallel to the principal axis in our syllabus. So all these rays will go back to what? To the focus. Parallel will go to focus. Parallel, focus. Parallel, focus. Parallel, focus. So they will meet each other where? Here in the focus. So the image will be a real image because it's in front of the mirror, because it results from the reflected rays themselves. Okay, but it will be too small, يعني light point. Okay, so this is the method that we use to make some small fire in papers in using sun rays. Well, I hope it's clear. طيب, let's see the next case. The next case, if we here the object is too far, it's an infinity, at infinity. Okay, here the object becomes closer, but the object is outside C. And I can say outside C, it means the distance between the object and the distance between the pole, which is called, we said that P, the distance between the object and the pole, it's more than 2F. It's more than 2F, because this is, remember, this is F. This is 2F. The object is here, so it's more than 2F. These descriptions are very important. What will happen now? We will send our reference rays. One parallel. It will reflect to the focus. The second to the focus, it will reflect parallel. Okay, Mr. The third, you don't have to send the third. You don't have to do that. Only two are enough with respect to you. When they meet each other, it means these two, the image will be formed here. So the image will be formed here. Okay, the point is represent the image of the head of the pencil or the object. So it's real image, and real means inverted. So real image, real, and inverted, or let's say upside down, okay, inverted, real. Where is its place? Its place between C and F. Well, between C and F, I can say, remember, QP is the distance of object. P, object, okay? Q, don't make interference with this point, which is the pole. Yani forget it. We will use P here. We will not use P here, okay? P is the distance from the object. Q is the distance of the object from the mirror. Q is the distance from the of the image from the mirror. So here between C and F, it means Q is smaller than 2F and more than F, because C at 2F, C at 2F, and focus at F. Okay, is it enlarged? Is the object enlarged here? No, it's not enlarged, it's diminished. Okay, it's smaller than, it's smaller than, it's clear that not the object, I'm sorry, the image is smaller than the object. I see it clearly. Well, this is the second case. The third case, by the way, we have to memorize and be able to sketch these cases. This third case is a very, very important case, because this is the case where the size of the object equals the size of the image. And the distance of the object, which is P, this is from the mirror, equals the distance of the image, which is Q, the distance of the image from the mirror. Okay, let's look what we will do here. This is the mirror, this is P, this is the principal axis. Okay, point, this is F. Okay, this is C. I'll put the object here. I'll send a ray parallel. It will go through focus. The second one is through the focus. It will go parallel. If it's accurate, they will meet each other where? Here. So the image is formed here, and it's equal to the real object, the object. So where the configuration is, the object is at C. At C means, at C, C means to F, the center of curvature, to F, to the focal distance. F is the focal distance, if you remember. Okay, and the distance of the object is P, so P equal to F here. Okay, real image, it's real because it's from the rays themselves. Okay, at C, inverted because of real, so it's inverted. Magnification equal 1. Magnification equal 1 means the object is equal because, so the magnification equal 1, because we said that the magnification is the size of the image divided by the size, the size of minus the size of, not minus here, sorry, size of the image divided by the size of the object. Okay, so they are equal. So the magnitude of the magnification is 1, because we'll talk about the magnification more about the sign, but now neglect it anymore. Okay, let's clear drawing and go further. Okay, here the object, we bring the object between C and F. In the next, in the previous one, it was at C. We will bring it closer. Okay, so it's between C and F. Okay, sorry. Okay, so this is the object. What will happen? We will send two rays. This is the first one. Okay, yes. This is C or 2F, and this is F. We said capital F, the point, small f, the distance is called small f. Well, the object is where? The object is here. Okay. This is the first ray. It will be reflected through F. Okay. The second ray through F, it will be reflected parallel. Don't forget to put the arrows because this is a ray. Okay. So where will the image be formed? The image will be formed here. So this is the image. Okay. The image is enlarged here. So the magnification is more than 1. The size of the magnification is more than 1, and it's real. It's inverted. Where is it? The image distance, which is Q, is more than 2F, because this is 2F. I hope it's clear, inshallah. Well, this is a very important example. Here we bring the object closer. So the next step is F. Okay, so the two rays will be parallel, as I explained a few minutes ago. Well, this is one of the most important cases of the concave mirror. Why? Because if you observe in all the previous cases, the image is not virtual. Okay, it's almost real. Sometimes no image will be formed, sometimes too small, but it's not virtual. In this case, when we bring the object closer to the mirror, okay, so behind or beyond or between the focus and the mirror, what will happen? This is the only case where virtual images form. So I want you to be able to say that if I tell you that a concave mirror, in any problem, if I tell you that, concentrate please, a concave mirror forms a virtual image of an object. You have to tell me, stop, I can guess the position of that object. Where is the object? The object is between the or inside the focus. Okay, why? Because this is the only case where the concave lens can form. Sorry. This is the only case where the wave can form, where the image can form virtual image. The object can form virtual image. Okay, how are they formed? Sorry, this is the object F, 2F or C. The object's here. This is the first ray, parallel, so it will go to the focus. The second object is the second ray is through C. Why, Mr. C? Because it's difficult to sketch it through, not through C, yani along C, because it will, you will make it here, it will reflect along itself. Okay, so the two objects are not meeting are not converging. So if you extend them, they will meet each other here behind the mirror. Well, okay. So now, inshallah, we will talk about the ray diagram of convex mirror. Let's see together. Remember, the convex mirror is like that. This is the convex mirror. Okay, or let's make it. Sorry. Convex means diverging. So this is here, this is the reflecting surface. This is the reflecting surface. Where is C and F? This is F, sorry, F, and this is C. They are behind the mirror. So if I ask you, can you guess the sign of the focal distance here? Yes, it's negative. Can you guess the signs of R here, R which is 2F, by the way? It's negative. Why? Because they are behind the mirror. This isn't problems. I make interaction. I know that we didn't study these signs, but this is some approach, okay? Where? Well, where will we put the object? We will put the object here. because we don't put the object behind the mirror, we put the object in front of the mirror. Okay, so the object is in front of the mirror. I'll make two rays. The first one parallel to the principal axis. So when it's parallel to the principal axis, where will it go? It will reflect such that its extension goes to the focus, because the ray is not able to go to the focus here, and this is not reflection. Okay, so it reflects as if its extension goes to the focus. Well, where is the other ray? The other ray is passing along the center of curvature, like this. Its extension passes through the center of curvature, so it will reflect on itself. Where the two extensions will meet each other, okay, here in this point, so the image here is virtual. If it's not clear, let's see it together. It's diverging, by the way, huh? This is the object. This is the mirror. It's convex, so it diverges light. This is the focus. Let's see what will happen now, inshallah. Look, from here, we will send the two rays. This is the first one. It's parallel. Someone may say, Mister, it will go to the focus. No, the focus is behind the mirror. It will reflect such that the reflected ray is along the focus, like this. Look, from here, this is the reflected ray, such that its extension passes through the focus. This is the second ray. The second ray is here. We can make it parallel to or passing along the focus. Okay, so it will reflect parallel like this along the focus. Parallel. We can make it along the center of curvature. Okay, so these are the two rays. The two rays, look at the pointer. The two rays, one is going here and the other is going there. So they are diverging. Okay, so they are diverging, so they can never meet each other. And I told you that if the two rays are moving, are reflected from far from each other, make their extension meet each other. Okay, so I'll extend the first one and I'll extend the second one, so they will meet each other here. Okay, whenever or wherever they meet each other, this is the image. So the image will be formed here in this position. Okay, so it's virtual image. It's virtual image. By the way, it's diminished. It's smaller than the object. Okay, well, so we finished this point. Let's see the next slide. Okay, this is the diagram that we sketched or we observed last period, last slide. This is the object. This is the first ray. It reflects such that extension passes through the focus, okay, because it's parallel. This is the second one. The second one is passing along the focus, so it will reflect parallel. Okay, I'll extend them. They will meet each other here. Someone may say, Mister, we may reflect, we may sketch the third one such that it passes through the center of curvature, as I made when I drew or sketched it in front of you. Okay, so it will reflect on itself. So these 3 points should meet each other in one. 3 rays should meet each other in one point. So this is the position of the image. It's behind. So it's virtual because it's from the extensions. Okay. If you look at this figure, you will find a small image, smaller than the object. Okay. If you observe that well, okay, the image is behind the mirror. Clearly, it cannot be projected on a screen, as we said. Okay, so the virtual image is upright, and it's smaller in case of the concave and convex, but in case of concave, it's enlarged, if you remember. Well, now we will talk about a very important point, which is the spherical aberration. Okay, what's meant by the spherical aberration? It's expected, look at me, this is the convex. Okay, we expect that the convex lens, the convex lens will make all the parallel rays meet each other in a point. This point is called what? Is called the focus, as we said. Well, but in the real life, we found a very strange phenomenon. These 2 points, look at the pointer. These 2 points here, this point here, and the other point here, which are the points far from the pole of the far from the principal axis, instead of reflecting the rays to the center of curvature exactly, they reflect the rays behind the center of curvature. Instead of reflecting the rays to the focus exactly, they reflect the rays behind the focus. So that makes the image blurred. Okay, so this phenomenon is due to what? Is due to the large distance between the sides or the terminals of the mirror and the center of curvature and the center of curvature. Okay, so to avoid this point, we try to, or this disadvantage, we try to make the outermost sides of the outermost points, those 2 edges of the mirror, closer to the center of curvature. Yani, in other words, we try to bend this. We try to bend this. Well, let's see. First of all, let's talk about this point, spherical aberration. It's a phenomenon that causes image of spherical mirrors to be blurred. It's not clear, okay? Because of parallel rays far from the principal axis converge away from the mirror's focal point. So we will bend this mirror slightly. Yes, like this. To make these points closer to the center of curvature to avoid this phenomenon. Let's see how. Okay, this what we did. This type of mirrors is called parabolic mirrors. Okay, so the parabolic mirrors are used to eliminate spherical aberration. Okay, why? Because all parallel rays converge in parabolic mirrors in the focal point. So that eliminates what? That eliminates the aberration. Well, now let's make a very important comparison between the concave mirrors and the convex mirrors. Okay, and let me remind you that concave mirror means converging mirror, and convex cave means diverging mirror. Okay, this is a mirrors only because it will be the opposite in lenses, inshallah. Well, the concave mirrors can produce both real and virtual images. Yes, when we studied the cases of the concave mirrors, we said we found that they may be real, they may be virtual. But in case of convex mirror, they produce only virtual images. Virtual images. And virtual and diminished images. Diminished, I said diminished means smaller. Well, sign conventions. This is a very important point to their problems. If you remember, we studied two formulae. These formulae were 1 over F equal 1 over P plus 1 over Q. This is the first one. The second one is M equal H dash divided by H equal negative Q divided by P. Here, in the problem, he will give you the focal distance, for example, 10 centimeters. You will not use it before making sure is it 10 or positive 10 or negative 10. From where we know from these conventions. So we have to understand them well. By the way, they are easy to be understood. Look, if we have the mirror. In front of the mirror, anything is positive. Any distance in front of the mirror is positive distance along the principal axis. Behind the mirror, any distance is negative. Well, what about the size of the image? The size of the image, if it's up, so it's positive. So if the image is upright, the size of it will be positive. The size, H. If it's down, okay, H dash. H dash, the size of the image. H, the size of the object. If it's down, so if it's inverted or upside down, it will be negative. Well, alhamdulillah. Sign conventions R and F positive in case of what? Concave. Why? Because this is the concave. This is the concave. This is the reflecting surface. This is F. And this is R. What R, mister? I told you R is to F. Double the focus. R is the radius of curvature. Okay? Well, both are in front of the mirror, so they are positive. It's logic. طيب. What about the Q, which is the distance of the image? Well, it may be positive if it's in front of the mirror. Okay? If the image is in front of the mirror, it will be positive. Which image is in front of the mirror? It's the real image. So if it's real, it will be positive. It's so easy. If it's virtual, it means the mirror, the image is behind the mirror. So it will be negative. Okay. What about H dash? What's H dash? H dash is the size of the image. It's always opposite to Q. What does it mean? For example, if the Q is positive, positive means what? Means it's real. Real means it's upside down. So H dash will be what? Upside down. So it's inverted. So it's inverted. So H dash will be excellent. Will be negative. Okay. So you have to memorize that the H dash is always opposite to Q. If the Q is negative, Q the negative means it's the distance from the mirror is behind the mirror. So the Q the image distance behind the mirror. So it's virtual. So it's virtual. So it's upright. Upright means the H dash is positive. Okay. So this is the image. If it's up, the H dash positive. Down, H dash negative. Well, what about P and H? P is the distance of the object. H is the height or the size of the object. They are always positive. Or let's say almost positive, but too almost, if it's correct يعني, to say that expression. Mr. Can they be negative in our syllabus and in our problems? No, concentrate in this case here, inshallah. Well, the sign conventions of the convex mirror, okay? The convex mirror is this, okay? Where is F? Where is C? So F and 2F behind the mirror, so both are negative. Q is always virtual, so it's also behind the mirror, so it's always negative. H, this is virtual, huh? Virtual means it's up, so H dash is positive. So easy, okay? P and H are always positive. Inshallah Rabbil Alameen, Alhamdulillah Rabbil Alameen, we finished this part. Next period, Inshallah Rabbil Alameen, we will discuss the problems or the mathematical skills together, Inshallah Rabbil Alameen. So, Inshallah, next problem, next period, Inshallah, will be mathematical skills, Inshallah. Okay, thank you, everyone.